WPA or WPA version 1, as is referred to sometimes, primarily uses the TKIP encryption algorithm. TKIP was aimed at improving web without requiring completely new hardware to run it. WPA2, in contrast, mandatorily uses the AES CCMP algorithm for encryption, which is much more powerful and robust than TKIP. Both WPA and WPA2 allow either EAP-based authentication using radius servers for enterprise or pre-shared key (PSK). PSK is vulnerable to a dictionary attack. The inputs required for this attack are the four-way WPA handshake between the client and access point and the word list that contains common passphrases. Then, using tools such as AirCrackNG, we can try to crack the WPA WPA2 PSK passphrase. It's important to note here that in this attack, you are as good as your dictionary file is. If the key is found in the dictionary that you are using, chances are that you will obtain it, otherwise the attack will fail. You can, of course, try with another dictionary file and maybe you'll succeed. In other words, we will use words that are located in dictionary files, files that contain large amount of words, in order to find out the WPA or WPA2 key. If the WPA or WPA2 key is more complex, you will need more complex words in order to crack it. Let's get to practice and enable WPA2 as the security mode of our access point. For that, I will navigate to the Wireless tab and from here we'll choose Wireless Security. As a security mode, we will choose WPA2 Personal. We'll leave the TKIP as the WPA algorithm and we'll need to provide a shared key. Now, in order for us to succeed with the attack, the key provided here needs to be found in a dictionary file. By default, Kali Linux comes with several dictionary files that can be found in the user share dict folder. So let me switch to the PuTTY application, which is already connected to the Kali Linux machine running on the Raspberry Pi, and use the ls user share dict command in order to display the content of that folder. As we can see, there are several dictionary files available, most of them being archived, but the last one, called words, is not archived. Let's take a look at its content by using the cat user share dict words command. The cat command can be used to display the file's content on the screen. As we can see, the file contains many words ordered alphabetically. But how many words are here? We can find out by issuing the previous command again and appending a vertical bar followed by WC, which stands for word count, and the -L option. This will count and display the number of lines of text available in the file. As each word is written on a separate line, we can assume that the number of lines is equal to the number of words. So there are 234,937 words in this dictionary. Not bad. However, depending on the complexity of the WPA2 key, this could not be enough. To simplify things, I will pick a word from this file and use it as the WPA2 key, so we can be sure that we will be able to crack the key. So I will again display the content of the file and will pick a word from it. We will pick one from the beginning of the file, so the cracking process should be fast. We will also need to pick a word that is at least 8 characters long in order to be accepted as the WPA2 key. This one looks good, aronitic. I don't know what this means, but it doesn't matter now. We will use this word as the WPA2 key, so I will paste it into the access points interface. Next, we need to save and apply the new settings. Now let's get back to the PuTTY window and check if our wireless adapter is in monitor mode already. For that, we issue the airmon-ng command, and as we can see, the adapter is in monitor mode and is using the Mon0 interface. Next, let's display a list of available wireless networks by using the aerodump-ng mon0 command. The wireless network that we are interested in is Wireless Lab, and we can see that this is using the WPA2 encryption. Let's copy the MAC address of the access point and use it to obtain more information about this specific wireless network. For that, we use the aerodump-ng command followed by --bssid and the MAC address of the access point. --channel, and this will be 6, and --write in order to save the wireless packets into a file, and we will call it WPA. Oops, I forgot to provide the interface that we are going to use, so we'll issue the previous command again and we'll add mon0 at the end of it. As we can see, no client is connected to the access point. Let me connect my phone as a legitimate client to the wireless network and let me grab the key first, Aronitic. Okay, as soon as the client connects to the network, we can see the WAP handshake message in the upper right hand corner. We can now interrupt the program and verify if the handshake has been saved in the file that we specified. We use the ls-la command, and indeed a file called WPA, which has the cap extension, is available. This file contains the captured handshake. Great! Let's try cracking the WPA key as we have the necessary information available. All we need is the file containing the handshake and the dictionary. To crack the key, we use the aircrack-ng command, followed by the WPA file that we just saved, the one with the cap extension, and the -w option, which allows us to specify a dictionary file that will be used to crack the key. In case the key used by the access point can't be found in the dictionary file, the attack will fail. But in our case, we have specifically set up the WP2 key to be a word available in our dictionary, so we should succeed. So I will again specify the name of the dictionary file, which is located in the user, share, dict folder, and its name is words. Great, now let's run the command and finger crossed. Success! As the key has been found, pretty fast I can say, in the dictionary, we were able to crack it. We have our key, Aronitic. Now if the key was in the dictionary but at the end of it, the process will also succeed, but it will take more time. So far we have used the Raspberry Pi without any restrictions in order to perform our penetration testing, but this could be a situation when a faster machine could track the WPA2 key much faster. So if you have access to a faster computer running Kali Linux, you can run the aircrack command on it in order to try cracking the key faster than if you were doing it on the Raspberry Pi. Anyway, the Raspberry Pi gets the job done and pretty fast also. This is just one of the situations where a faster computer could make a difference, but so far the Raspberry Pi has served us well. And finally, let me change the WPA2 key in the router's interface to demonstrate that we will not be able to crack it if it can't be found in the dictionary file. So I will simply add a number at the end of the current key, let's say 22. Let's save and apply the settings and let's start from the beginning. We'll use the aerodump-ng, follow it by the --bssid option to provide our access point MAC address. Then the channel, which is 6. The --write option to save the handshake in a file called WPA2 this time. And finally our mon0 interface. Next, let me connect my phone to the network as a legitimate client, and we can see the WPA handshake message in the right hand side corner. Let's interrupt the application as we got our handshake information, and let's check for the presence of the WPA2 file. Indeed, the file is present and has the cap extension. Finally, let's use the aircrackng utility along with the WPA2 file that has the cap extension, and then we specify the dictionary file that we want to use, which is located in the user share dict folder, and its name is words. If you remember in the previous example, when the key has been found in the dictionary, the cracking process only took a couple of seconds. In this case, as the key is not found, the process should take much more time, and at the end of it, it should report that the key has not been found. So, to conclude, in order to be able to crack the WPA or WPA2 encryption key, we will first need to obtain the handshake data exchanged between a legitimate client and the access point. In case that the client is already connected to the access point, we could send a couple of deauthentication packets in order to force it to deauthenticate and then reconnect with the access point, allowing us to grab the handshake data. Then we need a dictionary file, a very large one if possible, as this is our only chance to crack the WPA2 key. If the key could not be found in the dictionary file, the cracking process will fail. So, unlike web, which is flawed by design, WPA and WPA2 can be used to protect your wireless network with the condition that you are using a complex key, something containing both literals and digits. Thanks for watching this lesson and see you in the next one.